Hello everyone. This is a video presentation of EL06. So this is a calibrated signal generator board, which basically generates 10 volt, 20 volt, and 20 milliampere constant accurate signal, which are going to apply to the all these sensors, which are going to connect with the main IoT hardware. So here you can see the voltage configuration, which generate the 10 volt and 20 volt, and beside that you can see the 20 milliampere constant current source generator, which is load compensated as well. So we have used a temperature sensor to maintain the constant temperature of the printed circuit board, and you can see the array of resistor. And here we have used the ESP32 as an host processor to uh, to control the mode, and for the and to the switching the mode. And for the switching device, we have used the opto isocoupler to switching between voltage source and current source, and between the 10 volt and 20 volt voltage source. And this here you can see the screw terminal where we will get the voltage and current source output signal. Now we will move on the printed circuit board. So this is a PCB layout of the schematic. So here you can see these are the two peninsula that protects the rest of PCB from the heat produced by source component above those two peninsula. So this is the overall PCB layout. So this is a 3D view of the circuit board. So here you can see we have used the DIN rail, which is perfectly suitable for the industrial application. And these are the two screw terminal where we will get the output signal. Here you can see below the board, we have arranged the heater resistor to maintain the constant temperature of the source component, and which are isolated by two peninsula from the.
Now I introduce the main IoT block. And here is schematics. This one is diagrams we use. First one will be the main processor ESP32. It's built in the Wi-Fi, so all the data can be transferred by wirelessly. Second one is the power supply. Power supply is input from 9 to 24 VDC, and the output is 3.3 volt. For stable and safety, we use more capacitor and inductor for the input because it is a high voltage. Next one is a real-time clock. Real-time clock is we use MCP 7940N. This provides accurate day and time. So in addition to allowing the device to regulate the timing and the speed of the on function, even disconnect the main power supply. In this one, it's a crystal with a frequency 32.768 kHz, and it's have a two resistor here with they will generate high heat. So for the protect the device, we create a temperature sensor. This one here. The next one is 6-pin input. 6-pin input we create is a digital input for dry contact opener or letter collector. Next one is two inputs that can be independently selected as operate as a both digital channel. 0 to 24 volt mode, 4 to 20 milliampere current loop. So we use this circuits to control about the volt mode and the current loop. Next will be the PCB layout. PCB layout is here. So you can see this one is a ESP32. This one will be power supply. This one is will be real-time clock. And in the real-time clock, it's have two resistor with a high heat, and we push the temperature sensor here this one to measure it about the temperature. Yep. And next one will be the 3D view. The 3D views here you can see. It's have a two LED and one switch. Two LED will show you the status, and the switch will help you to reset the device. Yeah, this is the last device I want to introduce you. So this is the last device of our project, the power adjustment and power analysis. This device used for the analysis, power control, current control to support the other IoT device. It's have a three part here. The first part is power current control units. We use INA226Q1. It's a power and control and a current controllable device. And this device monitor both the sun voltage drop and the bus supply voltage. The next part will be the main processor. Main processor we use a develop board QTPY4600. This one we can create the code to control the INA226 to get the power and the current that we want to use. The next part will be the relay voltage grid. This one is controlled by the develop board QTPY4600. This one we can create the code to control which gate of the relay is open and another gate is closed. So it's have a two pin here. Yes, you can use two pin for many purpose. The next one is PCB layout. So this is the PCB layout, the power adjustment. As you can see, this device there were not just a footprint. So which will fit for the device in the library, so we can create this one in order to use for the outboard. Here we are using the 20 millimeter thickness of the line for the sun resistor because it's carry high current. And this one is a 3D view. As you can see, it is a small device. So this is our videos from our project. Thank you for watching.